The classical example in the fuzzy set theory is tall men. The element of the fuzzy set tall men are all men, but their degree of membership depends on their height as shown in table here. Suppose for example, Mark here at 205 cm tall is given degree 1, and Peter 152 cm is given the degree of 0. All men of intermediate height have their own intermediate degrees. They are all partly tall. Obviously, different people may have different views as to whether a given man should be considered as tall. However, our candidates for tall men could have the membership presented in this table. It can be seen that the Krebs set asks the question here. If you take a look at the Krebs set, it's actually giving the question, is the man tall? And it draws a line, say 180 here. Okay. Tall men, all tall men are above this height, and not tall men are below of this height. But then in contrast, the fuzzy set asks, how tall is the man? How tall is the man? The answer is the partial membership in the fuzzy set. For example, Tom is 0.82 tall. In our case, the fuzzy set of tall men maps height values into corresponding membership values. As can be seen in figure 1 here, David, who is 179 cm tall, so David is somewhere around here, which is just 2 cm less than Tom. So Tom is 181 cm, no longer suddenly become a not tall or short man as he would be in the Krebs set. So for example, if David is in Krebs set, it will be considered as not tall. Even though David is just 2 cm less than Tom, who is 181. So now David and other men are gradually removed from the set of tall men according to the decrease of their height. In previous slide, we have seen the universe of discourse and the degree of membership in fuzzy graph. The horizontal axis represent the universe of discourse, so it is the x-axis. It is actually the range of all possible values applicable to a chosen variable. So in our case here, the variable is the man height. So according to this representation, the universe of man's height consists of all tall men. Meanwhile, the degree of membership is the y-axis that represent the membership value of the fuzzy set. In our case, the fuzzy set of tall men maps height values into the corresponding membership. So, what is fuzzy set? So, actually, fuzzy set theory imposes fuzzy boundaries. Say we have a fuzzy set of A, it is a universe of X, and then it is defined by a function mu A, and this function is called membership function of set A. So for mu A x, where x is the value of from finite value of 0 to 1, where there are three functions here. If you take a look at this, okay, number 1, x is totally in A, then the membership function will become 1. If x is not in A, then the membership function is 0. There is another value here, that is, if x is partly in A, okay, then these are the value. It must be in the range of mu is more than 1, mu is more than 1, sorry, mu is less than 1, and mu must be more than 0. So this is what we call as the set allows a continuum of possible choices from this statement here. The degree of element between 0 and 1 represent the degree of membership, also called membership value of element in set A. So how are we going to represent this fuzzy set? So for the sake of convenience, usually fuzzy set is denoted as this one. So for example, A, this is set A, okay. So we have the membership function here, okay, the value, the degree of membership. So this is the degree of membership because we are dealing with X as well. And then xi here is the value of the element. Okay, so this is degree of membership. Okay, for one element up till n element. So for example, you have 10 element. So this is element 1 until element 10. Okay, so these elements belong to a finite universe of discourse of set A. Okay, so how are we going to represent the fuzzy set of Tolman in previous table? So remember our table here. So we have, this is the element, this is x, and this is the mu x, mu A x. So this is the x-axis and this is the y-axis. So for example, if we take a look at Peter here, okay, Peter here has element of 152 with degree of membership as 0. So how are we going to represent this? This is the way of representing it. So A is equal to the first element x1. So this is the second element x2 up till the last element. For example, xn. Sometimes instead of we using the plus sign, we can also use the comma sign here. Okay, 0 over 152 comma 0.01 over 155.